Welcome to Maths with Bob. Today we're looking at regions, and we want to first of all have a bit of an introduction to a region. And I'll just draw a line. You can see here. Let's actually make it go through, say, a point. Say, make it 3. Okay. Now this line actually splits up the number plane into 3 regions. The actual equation of the line itself. This line is actually called x equals 3. Now, on either side of the line, there are the regions. X over here, x is actually larger than 3. Now, if I have the line solid, it would be larger than or equal to 3. And on the other side, I'd have x is less than or equal to 3. So these regions, I mean, we normally would say shade a region. So we can just shade this region over here. You can see this region on this side would in fact be x is larger than or equal to 3. Okay, now on the other side, obviously we sketch the other side. Okay, over on this side, this is the region x is less than or equal to 3. Now if I change my line to a dotted line, okay, so let's actually do that. Hold on. Well, okay, I've changed my line to a dotted line now. The boundary is still x is equal to 3. Okay, that would be the boundary. And on this side would say, okay, instead of x larger than or equal to, x will now be just larger than 3. And here, obviously on this side, x is going to be less than 3. Okay. All right, so you can just see the inequality symbol is quite important. The actual boundary of the region is determined, whether it's whole or dotted, by the inequality symbol. If it's less than or greater than symbol, then obviously the boundary is dotted. Okay, and if it's a less than or equal to or a greater than or equal to symbol, the boundary is whole, or if you like, the boundary is actually included in the region. Okay, let's have a look along the y-axis now. Well, okay, we've actually now changed the line to a horizontal line. It goes through a point, say, on the y-axis. Let's call this point, say, 4. And you can see the boundary is actually just this line here, which is called y equals 4. So y equals 4 is in fact the boundary to the, well, I guess creates a region above and below, and we can see here that above y would be now larger than 4, and below y is less than 4. Now, if I wanted to make it greater than or equal to, you know, the line y equals 4 would have to be a solid boundary. Okay, this is fairly simple. I mean, above is greater than, and below is less than, and to the left, obviously, on the if I draw x is equal to something, to the left is less, and to the right is greater than. Okay, now what happens when I start to change my lines from, instead of from, you can see here, horizontal or vertical, to actually inclined lines, normal equations of lines. So we'll have a look at that next. Okay, let's draw a line, and we'll just draw, okay, some sort of line here. That's actually, okay, let's make, okay, this point here, say 3, this point here, say 2. Okay, what is the equation of the line? Well, we could write, oops, delete that little spot there. Okay, what is the equation of this line? Well, okay, it would be, okay, we know its slope is what? 3 over 2. We know it goes through 3. But we know the line is, okay, we know the line is bending backwards. We know it has a negative slope. So its equation would be y is equal to minus 3 on 2x, and its y-intercept is 3. Okay. So suppose we are asked to sketch the region y is larger than or equal to, say, minus 3 on 2x plus 3. Okay. Where is this region? Okay. Okay. Well, this now bodes a question as to what side of the line is the region on. Now, how we determine what side of the line the region is on is by picking a test point. Now, we normally pick a test point which is not on the boundary. Now, you can see the boundary is going to be solid, but let's actually, we normally use the TP, or the test point, at the origin. Test point we're going to use is 0, 0. Okay. So what do we do with the test point? Well, we sub it in and just to see if it makes a true expression or not. So let's actually plug it in. Is 0 larger than or equal to minus 3 times 0, 3? So is 0 larger than 3? False. No, that is false. It's not true. Okay, so I'll just try to say false. Okay, so basically, what does that mean? Well, it just means that the actual region itself is actually on the other side of the line. How can we interpret this? The test point evaluated to be false. I like to think of it as, well, the test point is not in the region, or if you like, the region is not flowing down through or past the test point. Therefore, the region must be on the other side of the line. Now, obviously, if I had a region which would say y is just greater than minus 3x on, or 3 minus 3x on 2, I suppose you could say, plus 3, then the line should be dotted, or the boundary should be dotted, and hence not included in the region. Okay, let's actually have a look at another example. Okay, in this example we have two lines. We're actually going to look at the idea of what's called union and intersection. Sometimes called the union is or, and the intersection is and. So let's just make up some points here. Let's call this, say, 4, and this one, say, 2, and say this point here, 2, and say this point here, minus 2. Okay, so let's try and first of all get the boundaries. So you can see they're solid lines. So this boundary, we would y is equal to, let's have a look, has a slope of 1, so it's x plus 2. Okay, let's actually change the inequality symbol to say less than. Oops. Okay, let's pause that again. Hold on. Okay, so let's make that. I think what we're going to do, we're going to make that y is less than, has to be less than or equal to, since it's solid, plus 2. And now, what about the other line? Well, the other line has a slope of, see, 4 over 2, but it's negative. So the other line would be, so y, let's make it y greater than or equal to, let's have a look. The slope is minus 2x plus 4. Okay, so suppose we want to find, okay, the union and intersection of these two regions. First of all, let's try and find the regions. Okay, let's actually just pick a test point. Okay, we always pick the test point TP here at the origin. Now, is the test point, let's plug it into this first one, is 0 larger than or equal to 4? No. So the test point is false here. Okay. How about over here? Is 0, we're putting 0, 0, remember x and y are both zeros, less than or equal to 2. So this one is actually true. Okay, so basically what it means is the test point is in this region, which is actually coming down this way. So let's actually put that down, coming down this way. So the test point, this region is coming down this way. Okay. Okay. Just quickly. Okay. All right. Now, okay. So let's go back for another color. Okay. Now for the other line, the test point is not on the region. Therefore, the region is above it. Okay, up here somewhere. Okay. Now, something's happening. Yes, it's going green. Now, interestingly enough, the union, okay, would be, now what symbol is the union? Well, okay, the symbol for union is just a big U. Big U, just like that, for union. And that would be all that coloured in area, okay, apart from a little section over here, you can see here, apart from this section here, okay, that section over there would not be included in the region of the union. Now, how about the intersection? Now, the intersection is the symbol for intersection is an upside down U like this, sometimes written as and, so it's this region and that region. The U upside, the other way up is the or, is you could say it's this region plus or and or, well, I shouldn't say and, I should say this region or. That union like that means basically add the regions together, I guess you could say. Okay, so we're now going to have a look at the upside down one. This is the intersection symbol, which means this region and this region. And you can see here, the bit that's gone green is actually where the two regions actually overlap, and this is actually, so this is the region we were going to be concerned with over here. So what we want is, okay, this is the intersection region over here in the green. Okay, so this is the intersection section, if you like. Okay, it's that little, well, it's over, basically it's this section over around here. Okay, but that's the intersection part. Okay. Okay, now this actually gets a bit involved into logic, but is the corner point, let's put the point, sometimes we've got to do a bit of logic here. Is that point included? Obviously it is in this case, but we've got a true, now in the union, obviously true or true is true, and how about true and true is true as well. But if the lines become dotted, you have like, you can think of it like false. False or false. Is false or false? Now, is that true or false? Now, basically this comes into the logic of false or false. Okay, so let's actually have a look at some of these truth tables. But false or false is actually false. So I just want to show you a quick look here. So this is actually... we have, okay, some truth tables for the actual union and the intersection. Union is or, so you can see true or true is true, true or false is true, still, because one of them is true. False or true, okay, that's still true, but false or false is actually false. But when you do the and truth tables, you can actually see that, in fact, the only one which is actually true is true and true, because they both have to be true for it to be true. You can see here. Okay. All right, well, thank you for watching, and we'll do some more examples later. Bye for now.